So most important topic, integrations, method of integrations. Many of them are doing homework, few members are still not doing them and not posting the whatever homeworks on WhatsApp group. For them, see, daily I am posting one unit to one video to you. If you do like this means I'll just post to directly to them, those who are attending the class, those who are doing homeworks, for them directly I can make separate group of them. Then it will be very difficult for you to understand this one. This is the most important topic, methods of integration. You have to follow this topic by giving your 100% of concentration, because in class I may ask some questions, by seeing face I can understand who is understanding or not, but now I don't have that thing, right? I can't see your faces and I can't see who is following, who is not following, but still one hope is there, you can revise this one by reversing the video. This is one of the great option we have in YouTube videos. What you have to do is, while watching the video, watch from starting onwards, what I am using, what are the terms I am using, why I am taking T, where I will apply that one. So first learn this substitution method starting point. It has very big concept. This is the big concept. It has many things to remember. First thing, you have to remember the formulas of integrations. Then you have to remember the formula of derivatives. Both formulas are used in a single problem, that is substitution method. Got it? In substitution method, we are using integration as well as we are using derivatives, both formulas. Now I will explain you how to take the value of t simplification, then how we are using the t simplification in question. Okay, now if t is equals to, from where we get, that is different topic, just to go through with this one. If I get t is equals to log x, differentiating this one in total derivative form, that means t derivative means dt, or 1 derivative of t means suppose x is 1, because this letter is t, dt we have to take. Log x derivative 1 by x, because this is in x terms we are taking dx. Got it? Once again check this. If t is equals to e power x, I will write t derivative 1 dt, e power x derivative is e power x dx. Then if t is a power x 1 dt, a power x by log, you don't take, by log is integration formula, derivatives a power x log a into at the end dx. Similarly, if I have taken t is equals to x power 4, that time derivative of t is 1 dt, x power 4 is 4 into x power 3 into dx. Got it? Watch carefully, because everyone can understand this one. Most of the people in intermediate fail in 2b itself because of the formula. They will not learn formulas and they want to learn the topic, which is not possible at all. See, after giving formulas, I used to ask formulas number of times, then I will start the class. But here I have to take the class without asking the formulas. How can I ask formulas to you? That's why I have given homework. At least by writing you can understand one thing or the other. So if those who don't know the formulas, first learn the formulas, then watch this video. Okay? T is equals to, suppose x power 5 is there. So dt I am taking 1 dt is equals to 5 into x power 5 minus 1 dx. If t is equals to, suppose sin x is there. What about dt? 1 dt is equals to sin x derivative is cos x dx. If I take t is equals to cos x, then 1 dt is equals to minus sin x into dx. Achha, where we are using this t concept, that comes after this. Just learn how I am writing, how we are taking. Suppose if you find t equals to, or we are taking t equals to tan x. If I ask you what is t is equal to tan x, means immediately 1 dt is equals to secant square x dx, you have to tell me. That means differentiation value, then dx. If t is equals to 1 plus log x, so 1 dt is equals to 1 derivative 0, no need to write 0. Log x derivative is 1 by x dx. If I have taken t is equals to sin inverse x, that time 1 dt is equals to sin inverse derivative is 1 by root over 1 minus x square dx. If I have taken t is equals to tan inverse x, what is t? 1 dt is equals to tan inverse is 1 by 1 plus x square dx. These are the things which you have to remember. How to take t and how to use dt. Okay. Now coming back to questions. Where will use this t? How to use this t? Evaluate integral. Suppose integral x plus log x we have to find. What we'll do? Integral x dx we'll take, integral log x dx we'll take. Then we'll have x power 1 plus 1 by 1 plus 1. Integral log x is x log x minus x plus c. This will be the answer. Okay. Now, if evaluate integral, the question is integral log x divided by x is given to you. That time what we do? Suppose this is the question. We don't have u by v form in integrals. So we have to use, whenever you find any division or any multiples, you have to remember to take t to one part. What terms we have to take t? So t will be log values. If log values are not given to you, then t will be inverse functions, sin inverse, tan inverse, cos inverse, or t is equals to bracket parts, or t is equals to denominator values. Mostly t equals to power content values also. Now check it out, keep those things in mind. We saw log in this one, so immediately let I is equals to, we can have integral log x by x. See, in previous exercise what we have done, directly applying integral to all the values, taking dx and writing the answers. But here by seeing this question, what we have to do, take I, then take the value of log x as a t. Now just before this one, what we have done, if t we have taken to log x value, dt you have to do, dt is equals to log x derivative. When we are taking t to any value, why I am not taking x to t? Because when log x is there, no need of taking any other value as t. If log x is not there, check whether sin inverse is there or not. It is also not there. Brackets are also not there, denominators and power values. So in that way, dt. Now these two values we have to substitute in this question. Log x. What is log x? T. Log x is gone. 1 by x dx. 1 by x dx is how much? Dt. 1 dt or dt. Don't take dt in denominator, just take beside that. Now think this total thing is in x form. X power 1. 1 plus 1 by 1 plus 1 plus c. So this is t square by 2 plus c. This is replace the value of t or recall it, log x. This is the question. Integral e power tan inverse x divided by 1 plus x square dx. What we have to think? See, these are exercise questions only. I am selecting the questions. First we will go through the concept. Then we can go through the serial wise. We can go number wise, whatever numbers are given to you. I is equals to one question I have taken e power tan inverse x by 1 plus x square. By seeing this question, we have to think that applying integral directly is not possible. So what we have to do? We have to take use of this t, that means substitution method. So which value I can take t? Many values are there. E is there, tan inverse is there, 1 plus x square. So I have given to you. Without knowing that also we can do directly by seeing the question also we can think which value is t. How can we get inverse is t? So remaining part is we are getting, so this is t value. In that way you can remember. Or you can think inverse values are always t. We will consider let t equals to tan inverse x. Immediately once we have taken t, what I told you to do for t? dt differentiation, total derivatives of this one, 1 plus 1 by 1 plus x square dx. Now this I becomes, these two things are replaced by these two in question. Integral same thing. E we have not done anything to e. Just we have taken tan inverse as t. Now what are the remaining things? 1 by 1 plus x square dx. This is the remaining thing. So what is the remaining thing? dt. E power t dt. This is the question. Now formula in terms of x. Consider this one to be a formula in terms of x. Integral e power x dx is e power x plus c. Replace. Recall the value of t here or resubstitute the value. This is substitution method. Check once again. This is the question. We can't apply integral to both the values as we have done in 6a exercise. We can't do in this one. So what we have to do? We have to think of t. Which term we can take? Many are there. Denominator is there. Root is there. Inner value. Many things are there. So we have to go through with this one. Log is not there. Inverse is there. So we can take t as inverse value. Then dt. Here derivatives you should know the derivative formulas. Now these two values we will substitute in I. Bracket part we have taken as t. Square as it is. Then don't take divided by, because if we remove these two, 1 by root over 1 minus x square dx, this total thing is dt. Here you can write. Now this is x power 2 dx. X power n plus 1 by n plus 1 plus c. So that is t cube by 3 plus c. T cube means what is the value of t? Sin inverse x whole cube divided by 3 plus c. This is the question. Multiples are there. Now what is t value? So we have to think log is not there. We can't take t for log. And inverse values are not there. We can't take inverse values also. Denominator is not there. This is also cancelled. Power value. Check power value to be t. Power value, we don't take e. This is 1 dt. X power n. N into x power n minus 1. This is dx. Now what we will get? E value. Power, these two values we have to substitute here. This is over. Then remaining is 2x dx. 2x dx is how much? dt. E power x integral is e power x plus c. E power x value is x square plus c. So this is I. This is the question. 3x square sine x cube plus 9. What you have to do? We don't know. So what you have to check? Inverse values are not there. We can't take. Log is not there. Denominator is not there. Power is also not there. So consider bracket as t. T equals to which bracket? Angle part. Then dt. When we have taken t, that time immediately you should take dt. Integral sine as it is. We have not done anything for sine. We have taken the bracket as t. Sine t into remaining. That whole thing will go. 3x square dx. How much is 3x square dx? dt. Integral sine t is minus cos t plus c. Minus cos, think in the terms of x, t value you can resubstitute. Okay? Follow these 5 questions. See this video minimum 3 times. Then we can have many questions tomorrow. Okay? Follow this short video.